Welcome to All Academic Channel, where questions matter more than answers. Your phone knows where you are almost all the time. It can guide you through a city you have never visited, help a driver find your exact street, and even remember where you parked your car. But here is the strange part: your phone can still know your location even when you are not making a call, not sending a message, and sometimes even when you have no internet. So how is that possible? How can a small device in your pocket figure out where you are on a planet that is more than 12,000 kilometers wide? The answer sounds simple, but behind it is one of the most fascinating scientific systems humans have ever built. Today we are going to uncover how your phone knows your location, explained by science. To understand this, we need to start with one important idea. Your phone usually does not find your location by asking, "Where am I?" Instead, it calculates where it is by listening very carefully to signals coming from space. That system is called GPS, short for Global Positioning System. Many people imagine GPS as if the phone is sending a signal up to a satellite and the satellite is sending something back. But that is not how it works. In most cases, your phone is not actively talking to the satellites. It is listening to them. High above Earth, a network of satellites is constantly broadcasting signals in every direction. These signals contain two essential pieces of information: where the satellite is, and the exact time the signal was sent. That sounds almost as simple. But from those two pieces of information, your phone can do something extraordinary. Right now, orbiting the Earth are more than 24 GPS satellites, moving at an altitude of around 20,000 kilometers. They circle the planet continuously so that, from almost anywhere on Earth, your phone can detect signals from several of them at once. Each satellite is like a clock in space with a known position. It keeps sending out a message that says, in effect, "I am here, and I sent the signal at this exact time." Now comes the key scientific trick. Radio signals travel at the speed of light, which is about 300,000 kilometers per second. That means if your phone knows when a signal was sent and when it was received, it can estimate how far away the satellite is. The signal's travel time gives the distance. This is the heart of GPS. Time becomes distance. Imagine a satellite sends out a signal, and your phone receives it a tiny fraction of a second later. That tiny delay may look meaningless, but because the signal is traveling so fast, even a very small difference in time represents a very large distance. If your phone calculates that it is 20,000 kilometers from one satellite, that tells it something important, but not everything. It means your phone could be anywhere on the surface of an enormous invisible sphere centered on that satellite. So one satellite is not enough. If your phone receives a signal from a second satellite, it can calculate a second distance. Now your location must lie somewhere on the circle where those two invisible distance spheres overlap. That narrows it down, but it is still not precise enough. Then comes a third satellite. With three distances, your phone can narrow its position much more accurately. In practice, a fourth satellite is often needed to correct timing errors in the phone's own internal clock. This process is called trilateration. People often say triangulation, but the more scientifically accurate term here is trilateration, because the system uses distances rather than angles. And that is how your phone begins to know where it is. But this raises another question. If GPS depends so heavily on measuring time, how can it be accurate enough? After all, light moves so quickly that even an error of a millionth of a second could change the result by hundreds of meters. The answer is precision. GPS satellites carry atomic clocks, some of the most accurate clocks ever created. These clocks are so precise that they lose or gain only tiny amounts of time over incredibly long periods. Without that level of timing accuracy, GPS would not work reliably. Your phone itself does not carry an atomic clock, because that would be far too expensive and impractical. Instead, it uses signals from multiple satellites to correct its own timing errors. By comparing data from several sources, it can solve for both its position and its clock offset at the same time. This is why receiving signals from more satellites usually improves location accuracy. But even this is not the whole story. GPS is powerful, yet the system has to deal with real-world complications. Signals can bounce off tall buildings, which can create errors in cities. Trees, tunnels, mountains, and indoor walls can weaken the signal. The atmosphere can also slow radio waves slightly as they pass through it. Engineers compensate for these effects using models, corrections, and extra satellite data. Modern smartphones also combine GPS with information from Wi-Fi networks, cell towers, motion sensors, and maps to improve both speed and precision. That is why your phone can often find your location faster in a city than in an open field. It is not always because GPS is stronger there. It is because the phone is using multiple systems together. GPS is the foundation, but your device is often smarter than just one system alone. Now let's step back and look at the history, because GPS did not begin as a convenience for maps and ride-sharing apps. Its roots are in war, physics, and space-age engineering. The idea of satellite navigation grew during the Cold War. Scientists realized that if satellites could be tracked from Earth using radio signals, then perhaps the reverse could also work. A receiver on Earth could use signals from satellites to determine its own position. This idea became more practical as space technology advanced. The United States Department of Defense began developing what became GPS in the 1970s. The goal was not to help people find restaurants or share locations with friends. It was to provide precise navigation for military operations, aircraft, ships, and missile systems. Accuracy mattered enormously. Knowing position quickly and reliably could change everything in navigation and defense. The first GPS satellites were launched experimentally, and over time the system expanded. For many years, civilian access to GPS existed but with limited accuracy. A deliberate error called selective availability was added to reduce precision for non-military users. But in the year 2000, that artificial limitation was removed, and civilian GPS accuracy improved dramatically. That decision changed everyday life. Suddenly, navigation systems became far more useful for ordinary people. Over the years, GPS moved from specialized equipment into cars, then into phones, watches, delivery systems, farming equipment, aircraft, ships, and countless digital services. Today, when you open a map app, it feels effortless. But behind that moment is decades of physics, engineering, mathematics, satellite technology, and timekeeping. And there is one more surprising detail. GPS does not actually need internet to tell you where you are. This is one of the biggest misconceptions people have. Internet helps your phone download maps, traffic data, and faster location assistance. But the core location calculation can happen without internet, as long as the phone can receive signals from satellites. That is why you can still know your position in remote areas where mobile data does not work, though loading a map in detail may be harder. So in the end, your phone knows your location because it listens to satellites, measures time with incredible precision, converts that time into distance, and uses trilateration to calculate where it is on Earth. It is a perfect example of science hidden inside everyday life. What feels like a simple blue dot on a screen is actually the result of orbital mechanics, atomic clocks, electromagnetic waves, and advanced mathematics working together in silence. The next time your phone tells you exactly where you are, remember this: signals from space traveled thousands of kilometers at the speed of light, and your device turned them into one simple message: you are here. Thank you for watching this video. If you enjoy this video, explore our Science in Daily Life playlist, where we explain the science behind the technologies you use every day. Don't forget to like, subscribe, and turn on the notifications so you never miss a question that matters.